Hey everybody! Today, let's get right down to business. We're going to talk about atomic orbitals. Well, let's see what atomic orbitals actually are and what types there are. Just what is an atomic orbital? So what does that mean in practical terms? An atomic orbital is a three-dimensional space where our electrons are likely to be found. But it's not always like that. The electrons might also be chilling outside the space, although that's pretty unlikely. Most of the time, our electrons are found right here in these spaces, which we call atomic orbitals. Well, that's about it for the definition. But what do these spaces actually look like? If I'm asking that, then there's got to be different shapes, right? Bingo! There are different types of atomic orbitals, and they come in various shapes. We've made a list of them for you. First, we need to ask ourselves, which types of atomic orbitals are there? Each type has its own shape. Let's take a closer look at the breakdown again. The orbitals are classified by letter. These would be the s, p, and d orbitals. There are also the f, g, and h orbitals, but we're mainly interested in the s and p orbitals, which are the most common. Okay, so what we have are different kinds of spaces, but what do they look like? You can picture the s orbitals as being spherical, just like a ball, and the p orbitals like little dumbbells. Maybe the electrons in there are trying to work out. Okay, all kidding aside. So just remember, s orbitals are always spherical and p orbitals are dumbbell-shaped. The shape can be explained by what's called the Schrödinger equation. As for how to calculate it, this equation describes the different shapes of atomic orbitals for the various types. To make this a bit easier to understand, it's best we look at an example. Let's take the element carbon from the fourth major group. Carbon has the electron configuration 1s superscript 2, 2s superscript 2, and 2p superscript 2. Now, we're interested in knowing which orbital shapes actually make up carbon. For this, we'll take a closer look at the electron configuration. It indicates that carbon is a combination of the spherical s and the dumbbell-shaped p orbitals. And that's really it for the orbital types. What should you remember about orbitals? Do you know what an atomic orbital is by now? That's right! A three-dimensional space where electrons are very likely to be found. And these atomic orbitals have different shapes depending on the type. Of these, we now know about the spherical s orbitals and the dumbbell-shaped p orbitals. Nice! With what we've learned, we can now describe the individual orbital shapes of these elements. When you've mastered the basics, you can continue by looking at how the orbitals are occupied by electrons in the next video. Until then, bye-bye!